Welcome, friends. We had a nice discussion on arriving at the boiler efficiency by direct method in the last lecture. We talked a bit about how direct efficiency method is very simple in the sense that it helps you calculate the boiler efficiency by taking only few readings when you go and actually do the audit on the boilers. So what 4 readings are essential then? So if you are doing an audit for estimating the energy consumption of the boiler, you need to just stand in front of the boiler, take a reading of the pressure on the pressure gauge which is provided on the boiler, read the temperature which is shown by the temperature indicators, and we have discussed that these temperature indicators are connected to the thermocouples. So a nice reading of the temperature of the steam, pressure of the steam, and the temperature of the feed water would help you calculate the output of the boiler. And how do we do that? We do that by referring to the steam tables. For measuring the fuel consumption, we discussed that there are different methods of measuring the fuel consumption depending upon the type of fuel in use. So for a solid fuel, we have a different method. For a liquid fuel and a gaseous fuel, we would be following a different method. So that was discussed in the last lecture. The advantage we said is the back of envelope calculations and few readings would help us to estimate the direct efficiency. Now, the major disadvantage of the direct method of getting the performance of the boiler is that it does not tell you where the losses are happening. So if it does not tell you where the losses are happening, we won't be in a position to intervene and reduce those losses. In other words, we won't be in a position to improve the boiler efficiency significantly if we don't know the sources of the losses. The second error we talked about, the second disadvantage we talked about was regarding the margin of error. If you make error in the fuel consumption measurement or in the steam flow rate measurement or even in the pressure and temperature, that error is going to magnify a lot, and that would show it in the final efficiency calculations. So to avoid these disadvantages, generally when we are talking about high capacity boilers in the industry, it is advisable to do the second method which we are going to discuss today. So the second method which we will be discussing today is known as the indirect method. Okay. So what is this indirect method? So this indirect method, you see over here in this neat diagram which is shown over here. I had shown the losses which are happening in the boiler. So one is the dry flue gas losses. Flue gas meaning the products of combustion. So the heat loss which happens through the products of combustion, that is one. Then there is a loss because of hydrogen in the fuel. Then there is a loss because of moisture in the fuel. Then there is a loss because of moisture in the air which is supplied for combustion. Then there is a loss because of incomplete combustion, which is reflected in the formation of CO. CO means carbon monoxide. Then there are surface losses because of conduction, convection, and radiation. And then there are losses via the ash, both the fly ash, which is escaping via the chimney, as well as the bottom ash, which is to be collected below the grate of the boiler. Okay. So these losses which happen, these losses, if we are in a position to measure those losses and calculate and do some preliminary calculations, and then sum of those losses, if they are found on the percentage basis and then subtracted from 100, would give you the boiler efficiency by indirect method. Okay. So this, let me explain you this in a bit more detail in the next slide. So look at the losses. I talked about the losses which are happening, and we had named them as L1, L2, L3, L4, L5, and L6. So all these 6 losses which are seen on the slide, they are the losses which are applicable to the boiler which is fired either by the solid fuel or the gaseous fuel or the liquid fuel. So in all these three fuels, you would find that these losses are predominant. Okay. So what are those losses? We talked about first the loss due to the flue gases, dry flue gases. This is a sensible heat loss, meaning what? The flue gases are formed because of combustion in the fuel. For example, if there is coal, if you are burning a coal in the boiler, and that coal, when you fire it, it would form carbon dioxide, carbon monoxide, and so on. So these are known as products of combustion. So these products of combustion are let out at a temperature which is much higher than the atmospheric temperature. And because of this, because the hot flue gases are being released to the atmosphere, they would carry away certain heat, and that heat is the sensible heat. So this is the loss. So the heat which is lost by the hot flue gases is the loss. Okay. Then there is a loss due to hydrogen in the fuel. Now what is this? How does hydrogen contribute to the loss? The hydrogen which is there in the fuel, and which we know from the ultimate analysis of the fuel, this hydrogen gets oxidized during combustion and it forms water vapor. So this water vapor, when it is formed, there would be the heat loss when the water vapor is formed, both for latent heat. Latent heat means the heat required for phase transformation. Okay, so the water vapor is in the gaseous form, and that hydrogen, when you combines with water or with oxygen, it forms water. This water, gaseous to liquid, this is the latent heat. Okay, and then it is also at a certain temperature. So because of the hydrogen in the fuel, there is a sensible loss as well as the latent heat loss. Okay, then there is moisture in the fuel which would be then evaporated. So there is again the heat loss because of moisture in the fuel. So you can imagine that if you are using a dry coal and if you are using a wet coal, obviously the efficiency would be less if you are using a dry coal, because there is certain loss in heating up that moisture, evaporating that moisture. Again, if the climate is humid, it means that if there is moisture in the air, and if you compare it in a situation where you are operating the boiler in a dry climate, you would find that the loss is more when you are operating that boiler in the humid climate. And why is that so? Because there is a moisture in the air which has to be evaporated, and that could consume certain energy from the fuel which is being supplied. Okay, so there is loss due to moisture in the air. Then there is a loss because of formation of carbon monoxide. Now, combustion phenomena ideally has to be a complete combustion phenomena, wherein the entire amount of carbon gets converted to carbon dioxide. However, in real life, the combustion is not that ideal, and you would find that some traces of carbon monoxide is also formed. Now, what is happening that when you are having carbon monoxide as a product instead of carbon dioxide, the carbon monoxide, when it is formed, it would release less energy as compared to the case where you are forming CO2. Because formation of carbon dioxide as well as formation of carbon monoxide, both are exothermic reactions. Exothermic in the sense that energy is released. However, less energy is released if you are forming carbon monoxide, and more energy is released if there is formation of carbon dioxide. So when you are having carbon monoxide in the products of combustion, there is a loss. So this, I hope you have understood that there is a loss because of incomplete combustion, incomplete energy released. And then you know that the surfaces of the boiler would have higher temperature, and this higher temperature surfaces would contribute to the losses in the form of radiation and convection. Okay, so that also we need to keep in mind, that if there is no proper insulation, the surfaces are at a much higher temperature, that is going to contribute to the heat loss via the surfaces. Okay, so all these losses, L1, L2, L3, L4, L5, L6, we can easily calculate, and that theory we will be discussing in a while. Okay, but these are the losses which are found in the boiler irrespective of the fuel used. But there are certain losses which are unique to the solid fired boiler. Now what are they? So let me discuss them. This are the losses because of fly ash and bottom ash. Okay. Now fly ash, if you do an analysis of fly ash, you would find that there is certain carbon content in it. Similarly, if you do an analysis of bottom ash, you would find that there is certain carbon in it. Now, when you see that there is carbon in it, it means that that carbon is not burned. And if you are not burning that carbon, it means that certain energy is lost. Okay, so certain energy is not tapped. So this is called as unburned losses. So there is unburned losses in fly ash. There is unburned losses in bottom ash. What is fly ash? Fly ash. The word is fly. Okay, so it means that the ash flying off via the chimney, and bottom ash means the ash which is to be collected at the bottom below the grate. So hence the term fly ash and bottom ash. So this, if you see the amount of fly ash and if you measure the amount of bottom ash, one can calculate the energy which is lost via the fly ash and bottom ash. So in the next class, we will be discussing how to calculate the different losses. But in this in this short video, what we discussed was these are the losses, that is L1, L2, L3, L4, L5, L6, L7, and L8. We need to sum up those losses, and we need to sum up in the sense that we need to calculate those losses as a percentage of energy in the fuel. Okay, so L1 means L1 would be L1 percentage, and what is that? It would be the energy which is lost upon the energy which is in the fuel supplied. Okay, similarly L2 is L2 percentage, meaning the energy which is lost upon the energy which is in the fuel. Okay, so this way you calculate. L7 would be energy which is lost in the fly ash upon the energy in the fuel. So if we can calculate this L1 percent, L2 percent, L3, L4, L5, L6, L7, L8 percentage, that total percentage has to be subtracted from 100, and that would give you the boiler efficiency by indirect method. Okay, so this, now to understand, if you look at this boiler efficiency calculation method, you would easily understand that we have calculated boiler efficiency by doing an energy balance. We have found out where the losses are happening, and then we can figure out where one should intervene. Okay, if you want to improve the boiler efficiency, and if we know, for example, that there are major losses via the flue gases, then we can make corrections. Okay, what corrections we should make, that we'll be discussing. But we can make those corrections, and then that particular loss would be reduced, and your boiler efficiency would be improved. Okay, so boiler efficiency method is highly recommended method. It gives you very good insights about calculating the boiler efficiency, determination of boiler performance, and hence intervention to save the fuel and save the money in boiler operation. Thank you very much.